Hello viewers, welcome to Quick Coder. My name is Tulasi. Today's topic is binary search in Java. So why binary search is required? Okay, so I want to explain this. Okay, this is the program for searching an element in a sorted array. Okay, so in sorted array we want to search an element. Usually what we usually do is linear search. Linear search is nothing but we will go from start to end and we will search for the element. If the element is found, then I will return 1, otherwise I will return -1. Okay, it's very simple. But one constraint they have given is they require time complexity of log n, but its time complexity is of n. So how can we do? We have some a very advantageous thing where, whenever we can see here something like sorted array. So searching in sorted array, but searching in unsorted array, so we can do like this only. So there is no other way. But here they gave something like sorted array. So in searching in sorted array, uh, using binary search, we can do this in log of n times. Okay, log n times. Okay, how can we do that? Let's start now analyzing that binary search algorithm. Then we can write this code. Okay. I have given me 15. I want to or else I want to find whether this 15 is present in this array or not. So anything we can use only one algorithm, that is binary search. Okay, first go with what is the index of this 15th element. Okay, what I usually do is simply we can take left and right pointers. Okay, left pointer point to this left side and right pointer points to this right side. Okay, let's change the. Okay, so this is my left pointer and this is my right pointer. Okay, I always points to this and I will find the middle of this. So what is my L now? My L is 0 and my R is 9. So what is my mid? Mid value is nothing but 0 plus 9 by 2. That is approximately 4. Okay, now I will check the fourth element. So my mid is here now. I will check the fourth element. So here by God's grace, so okay, we found 15 directly. Okay, then we can simply return this mid value. So return mid. Okay, as mid is pointing to the 15th element, so return mid. We find index. We found index now. So now let's take my k value is something like 23. Okay, now what is the index? Okay, again my L will be 0, my R will be 0, and mid will be 4 now. So pointing to the mid element 15, but it is not is equal to 23. Now I can easily say that if my mid is 15, that is it is less than 23. 15 is less than 23. So the remaining, as it is a sorted array, the elements before this 15 is also less than 23. So no need of searching this all the things now. So instead of this, let me take this L pointer to here. Okay, means my mid is pointing here. My L pointer will come to mid plus 1 position. As 15 is less than 23, the remaining elements will also less than 23 before 15. So I am taking this L pointer to here. Okay, now my L is pointing to 5th index. Okay, now 9 plus 5, 14, 14 by 2, 7. My mid will be 7 now. Okay, now my mid is here. So I found 23. So simply return 7. Okay, let's take my, instead of taking 23, let's take 21. Okay, then what will be the thing? So as my mid element 23 is greater than 21, now the 23, I mean the elements after the 23 will be also greater than 21. So no need of checking these elements. So I will take my R2 mid minus 1. Okay, this previous element. Now my L is pointing to 5 and my R is pointing to 6. What is 5 plus 6 now? 11. My 5 plus 6 is 11. 11 by 2 is 5. Now my mid will be pointing to 5. Now my mid will be here. Okay, again I will check. Is my mid value, that is 19, is equal to 21? No, 19 is less than 21. So instead of checking these elements, now I will make my L pointer to mid plus 1. Again my L pointer is now, okay, my L pointer is now at 6th position. So my mid will be 6 plus 6 by 2, that is again 6. Okay, what is the mid? Now my mid and my L, my and R are facing at the same positions. So mid value is 21. So I will return index 6. This much of simple algorithm. Instead of searching, these all the things we just shifted L to here, and instead of checking this 30 and 35, we shifted R here. So see, searching is decreased. Okay, so that's it about this binary search algorithm. So let's start coding now so that you can understand very well. Okay, but there is some constraint in finding this mid value. Usually we are finding mid is equal to L plus R by 2. Instead of doing like this, in most of the articles, you find like this L plus R minus L by 2. So why they are doing like this instead of doing like this? So what is the main cause behind this is, let's say our maximum value for int in Java is, that value is 2 power 31 minus 1. I will tell that value to you. That is 2, 1, 4, 7, 4, 8, 3, 6. Sorry, 83647. So this is the value of 2 power 31 minus 1. So the int value cannot exceed this value. So if it exceeds this value, you will get some negative value in place of mid. So your whole program will get wrong answer. So for suppose there are many elements, let's take 2 power 31 elements are there. So let's take 2 power 31 elements are there. And your index value somewhere will be 2, 1, 4, 7, 4, 8, 3, 6, 4, 6 and 2, 1, 4, 7, 4, 8, 3, 6, 4, 7. So these are the two indexes values. You're taken L and R by 2. Then you will obviously get this again 2 power 31 minus value. It exceeds that. So what you will do now? So let's take, you have more values greater than this. So when you are doing by 2 also, it may exceeds this mid value. Then this mid will be assigned to some negative values because it exceeds its integer range, 2 power 31 minus 1. So let's take some element is 2, 1, 4, 7, 4, 8, 3, 6, 5, 0. My L index, and my R is something like more than this element. So even we are adding this and even doing by 2, you will get elements in range of, let's take R as 2, 1, 4, 7, 4, 8, 3, 6, 5, 4. You will get the median value, like take 5, 2. At last you will get 5, 2. That is nothing but 2 power 31 minus 1 greater than this value. Okay, now it will assign some negative to this mid value. Instead of doing like that, so let's take L. L means something like this, and plus R minus L by 2 means you will get value less than this 2 power 31 minus 1 value. So that's the reason all the people prefer this arithmetic expression in doing mid value calculation. Okay, let's start coding now. Okay friends, let's start coding now. I'm taking my L as 0 and my R as n minus 1. Okay, n minus. Now while L less than or equal to R, what I'm doing is I'm calculating my mid value like L plus R minus L by 2. Okay, I will get my mid value. If my k element is greater than array of mid, then what I can do is, so as my k is greater than these values, so the before the mid values will be like something like, as I explained before, uh, before the mid, so there are some values, no, they are useless because they are also will be less than k. Now what I'm doing now is I am taking my L to mid plus 1 values. Okay, and again else if my k value is less than array of mid, then what I can do is I will take my r value to mid minus 1. Mid minus 1. Now else it is equal. If it is equal, then simply return 1. Otherwise return minus 1. Okay, let's run this code now. So this is very simple code, okay, simple to understand and very simple to implement. Okay, we got 1 because 6 is found in this element. Submit. Okay, correct answer. Okay, this is nothing but a binary search program searching an element, or we can say whether the element is present in this or not, or also we can say whether we can also return the index of the element we are searching. So like this we can do. Okay, so this is nothing but binary search algorithm, and I also explained why we are taking L plus R minus L by 2 instead of taking L plus R by 2. Okay, and thank you friends, thank you for watching this video. The coming up video is finding the first index and last index of an element in an array. For suppose if you are given an array and repeated elements are there, you have to find the first and last index of the particular element. Okay, so this also can be done using binary search algorithm. Okay, I will explain this all the things in the next video. So please subscribe to my channel to get notified for the future videos. Okay, thank you for watching.